Okay, so what I'm going to present to you is a real case of implementing an air traffic management twin in Kubernetes. So we've been working on this for the last almost 2 years, and we can actually share a lot of experiences on how you do that. Just to introduce ourselves, we are AirLab. AirLab is a collaboration between the Civil Aviation Authority of Singapore and Thales. And what we do is develop new technologies for air traffic management. So basically, when we are here, can you see where we are? Can you see Singapore in this? This is a strange map, right? People don't really know about this map. So the planet Earth is divided in FIRs. Yeah, I know it's not very common, but this is flight information region. So every part of planet Earth has some authority, some system managing the aircraft. Okay, and yeah, all this is about aircraft. It's air traffic. So you have taken a plane, right? So when you were, well, this is Singapore. Okay, so if you came to Singapore from Europe, for instance, you crossed all these borders, and every time that you were crossing one of these borders, your data was going from one system to another system through some very legacy interfaces and very old networks that have been working for the last 40, 50 years. Okay, and this is how air traffic management works. And the blue part is what my company does. Thales is managing all these airspace in the technology. Then you have the air traffic controllers that we will call ATCOs in this presentation, that are the ones that are actually doing the management. And the other actor in this AirLab is the Civil Aviation Authority of Singapore. The Civil Aviation Authority of Singapore is managing this FIR. Can you see the shape? Quite particular. Singapore is here, and we have all this part of airspace, which is connecting up to Manila. And this is the South China Sea, so it's a very interesting piece of airspace. So every time that a plane is crossing all this airspace, it could be somebody going from Malaysia to Malaysia in Borneo Island, you are crossing Singapore. And what is it that we have done? We have done an air traffic management. Why? Our systems, and in this case, the LORAS 3 system, that's the name of the system that manages air traffic in Singapore. It's, by the way, it's one of the less than 10 critical systems that there are in Singapore. So there are some, because if it fails, let's say that no more planes, is a safety critical system. What we do is keep the planes, the aircraft, the airframes, there are several names for this, separated in the sky. Why? Because if they come very close, bad things happen. Usually it affects between 300 and 600 people. So you cannot keep, you cannot innovate, you cannot do a lot of things that you could do in whatever other sectors you're working. So our need was to accelerate innovation, transforming the ATM business, trying to use APIs for the first time in aviation. And this is why we had to create a twin. The twin, the application that I was telling you about, LORAS 3, is a big monolith. It's been there for the last almost, not 20 years, but close to 20 years. And we broke it into a small parts. We deconstructed the monolith. We made it cloud native. Each part uses what we call a facade pattern. And a facade pattern means that you can put in front of the monolith some kind of API facade. And you can break using the different instances of the monolith in different modes. You have different services. In aviation, for instance, one is the tracking service. The tracking services make sure that the different signals that you get from the radars are consolidated. There is only one aircraft. There is only one airframe. But you can see several signals which are contradictory about this aircraft. So we simplify everything into the tracking system and follow where it is. Another one is the coupling system. You have a coupling service that actually relates the airframe with the call sign. It tells you this airframe or aircraft, okay, sounds strange, airframe, is in reality flight SIA 734 coming from Malaysia. Okay, that's a cause. And in this environment, what we did is, okay, let's create all this replica so that we can analyze all this data, because the data right now is locked inside the monolith, so that we can train, or so that we can try new functionalities. And I'll go back a little bit more about this. So one of the things that you will be able to see, if I can show you a snapshot, because the internet connectivity is not very good, is we are able now to analyze the data. And this is a simple thing that in many other sectors, it's the day-to-day. So probably you've heard about banks knowing about what their customers do and how to delight them and so on. Well, in air traffic, it's the first time that we're able to get data from the monolith. Usually, extracting the data takes a couple of weeks because everything needs to be safe and expensive. Safe means expensive, by the way. Or trying new functionalities, conflict detection and resolution. Right now, the system will tell you, oh, there's a conflict. Conflict means two aircrafts that are going to be very close together at some point in time. But it will not advise you, what is it that you could do? What is it that you should do? What is it that you should not do? So one of the prototypes we have developed is what we call the tactical controller tool you have in that corner of the screen, and the tactical controller tool. So the way it works is the air traffic controllers will give you a clear flight level, and a clear flight level which is in feet. So if you see these numbers, you need to add 2 zeros and multiply by 0.3, and then you will know the meters. Okay, basically 300 will be 10,000 meters. And from that clear flight level, maybe the air traffic controller will take you from flight level 300 into flight level 250. And then there will be another conflict. You are going to conflict with somebody else. And then you're going to go up to 280, and there will be another conflict, and you will be changing. And for instance, this functionality, it actually advises, hey, don't take them to 280. You will need to change them again. These things are new in air traffic management. So how does it fit with other things like getting recommendations from Amazon? The technology could do a lot better, but it needs to be safe. So far, we can only do it like this. By the way, we're going to be trying, so one of the prototypes we have developed that we're going to be testing in 2 or 3 weeks, and you may be in one of these planes, I like saying that. So it's, we have developed a prototype in which we identify which are the aircraft that can do continuous descent operation. What's CDO? We call it CDO. So when you're in an aircraft and you're going down, you will see that you go through different flight levels. So every time that you go to a different flight level, okay, aircraft don't have brakes. They cannot do sharp turns and things like this. But every time that you're going from one level to another, you are wasting a lot of fuel. We are wasting a lot of fuel. That's a lot of money for the aircraft, for the company, for the airline, and that's not good for the environment. A few years ago, we didn't really care. Now we can. And if you could descend an aircraft approximately 3 degrees, not exactly 3 degrees, you would be going in low thrust. You would be like planning a little bit, and you would save a lot of fuel. So one of the things that we have developed that we're going to test in a couple of weeks is an advisory system that, since now we have all the information outside of the safe system, we're able to identify which are the aircraft that should have priority for landing, so they can do a CDO without affecting all the flights. Because if in order to save fuel for one flight, you need to move 5 other flights, you are not saving anything. So this is an example of application. By the way, the Transport Minister gave us 2 weeks ago the Distinguished Award for innovation, because I think that there are not many things like this. But I wanted to tell you a little bit more about how this is done, okay? Because you can use it as a reference, because maybe you want to do something similar tomorrow. So everything is Kubernetes based, everything. The monolith is in one of these blocks on the right. Okay, all these services I will upload this. Don't worry. Or I can send it to you. There's a LinkedIn link somewhere. And all our functionality goes on the right. These are services. All the infrastructure goes below. Everything is Kubernetes. So in Kubernetes, you know that everything is a pod or a deployment or gets exposed as a service. Or in this case, what we do is we group pods, services, deployments that have a common functionality. For instance, what we call an ASD, which is a situational display. Okay, so we create a group of things that we call a capability. These are custom resource definition in Kubernetes. You can create as many capabilities as you want. But then you call that capability, and you assemble things like if they were pieces. My first advice when you're working in Kubernetes, this is difficult, yes, but it's scalable. Okay, don't restrict yourself to the basic things. Oh, I have these pods, these deployments, these services, I combine them. No, you can have much better building blocks, and you can build big things. And we have assemblies. Assemblies are a grouping of capabilities. You want some HMI, human machine interface. You want some backbone, which will be a Kafka. All this is event-driven. You have on the left the common services, and you want this to be building on top of Azure. In our case, we use Azure from Microsoft. So this is a twin. A lot of services that are common. One of the key things that we probably is quite specialized, what we call fake time service. Why fake time service? Why somebody in air traffic management does a fake time service? I don't know if you have seen the movie Die Hard 2, but Bruce Willis has to defend an airport, and there is some problem with the radar, some signal goes down. If the air traffic management systems have a lag of more than 1-2 seconds, they just kill all the signal. If I'm not giving you the right information, I'd rather not give you anything. And then you need to look at the window and take care of what's happening in your airport. This is very important for us. So all our monoliths, if we try to run them now with data from the past, they just break down. So when we are running a monolith with the data from the past, the monolith needs to be convinced that it's in the past. Why? Because the purpose of the twin is to replicate reality, is to have the same behavior, to be able to see what would happen to the system if there was another configuration, a what if case, and so on. So you really don't want to change the code. You want to wrap it, and you want to put it in Kubernetes in a proper way. So this is a conceptual model. These are the domain-specific services, and I know I'm going very fast, I'm sorry. These are the specific services that help build the twin. All these things configure capabilities, and then you have assemblies, which are also customer resource definitions based on capabilities that give you the use. The use cases are in the center. And all these things are a combination below of pods. But you don't really need to know the pods. You just really need to know, I want an HMI, I want a Kafka, I want to transform this data from this format to this format, and I want to be able to analyze it in. And this is how it works. We have all these kind of services. In reality, it's huge. We have several Kubernetes clusters, and they have 60 namespaces each, and 2,000 pods. We could check it now. And the key things is that we are able to do things, inject data from different sources, analyze, and so on. How does it work? Look, high-level diagram of an ATM Twin. We have the factory, which is all the CI/CD tools and so on that we use to create it. We have what we call the SDB, and now I'll present it to you. We are able to extract data from the real world. And that was for us the most important thing. We started this in 2021, and we were able to extract data from the real world 3 weeks ago. And I'll show you how it looks like. Why? Because we needed to get data from the system, from the real LoRaWAN system, without interfering with the real system at all, without touching it. So what is it that we do? We sniff the network. We mirror everything that is in the network, and we reveal all the packets. until we have the full information. But the original system is not touched anyway. We spy on ourselves. Then we create instances, and the twin can do as many instances as you want. It could be doing training, could be prototyping, could be the example that I was telling you before, is a prototyping. Everything is event-driven. So you have a backbone, Kafka, data lake. Here you have all the services, injection services for the past data. Why? Because it needs to be transformed accordingly with the fake time that I was telling you about and so on. You could be doing simulation. What happens if? You could be adding more planes. And then you have the core things, LoRa's 3. I'm talking about the system that really manages the aircraft today in Changi. And you have prototyping, digital voice, lots of services, session management, control monitoring. Obviously, identity and access are important. What I was telling you, building templates from assemblies and capabilities, very important. So I'm going to get more into details. But this is how it looks like. If we open a terminal and list the capabilities, I will see a long list of capabilities. And can be, this is an example of the capabilities I can show you. A simple prototyping session would have something like this. I did not count the boxes, but a lot of deployments, a lot of pods supporting these deployments, a series of stateful sets, 3, one job. I'm not sure why we use the job. Something needs to be initiated, and 10, 12 services. And the last presentation I was doing, I was deploying this live. Today I don't have time for this, but I promise you it works. And then we have the secure data breach, which I was telling you. It's the only piece that is not in the cloud. So this cabinet, which is in a hidden building somewhere in Changi, that you cannot find in Google Maps, is where we rebuilt everything. And this is the device that does the magic. Remember the shape of the EFIR? So once you connect this, you see it like this. This is what is happening. Can you see the Philippines over there? Can you see Borneo on the right? And Singapore is here. Okay, but this is, I think I took a random 5,000 flights with the SDB. Because if you do a twin and you do not connect it to reality, what do you do with it? And what I'm going to show you, I'm going to try to connect, see what happens. So right now I'm connected in one of our clusters. There are lots of nodes. You can see them, right? Yes. And you will see that, for instance, let's go to namespaces. And the namespaces will have somewhere sessions. Can you see the sessions? So every session, every compilation of capabilities is built within a namespace. So you clear the namespace, you clear the session, everything is very clean. Let's get to see this. So we are now in the ATM Twin of the dev cluster. And you will see that there are some sessions here going on. Yeah, Alex Chow just opened a session that wasn't here 5 minutes ago. And see what Alex is doing. Open this screen, a twin session spy. Okay, 7 in the morning. That's the time now, because we use UTC time. So in UTC time, it's 7 in the morning. So now we should be able to see flights that are coming. But before this comes, let's look at this. Okay, so this is a session C52. C52. Yeah, there's a namespace. There's no namespace, probably I'm in another cluster. But I want to go to workloads and I choose bots. Okay, I have a session. This was filtering something. Here you have a session. Doesn't exist. Open a session. You will see how this is done. Kubernetes. Is okay? Yeah. Oh, okay. So here you can see a session. It's being created. These are the different pods. You see that now it's creating a backend with the spy. It's just reconfiguring the session. And this is why you have the the orange things that slowly will turn to green and will allow you, yes, so I should be finishing, right? So now you can see things like the flight data. Here, for instance, if I remove this filter, I'm seeing filters, I'm seeing flights that were there on the 30th of September to the 1st of October 2019, which is something that you could not do before. Or you could be seeing, let's see if I can connect to something like that. Okay, open this one, create it, I'm going to open this one. I'll be kicked out any moment, but it would be nice that I can still, okay, these are the flights that we have right now. So this is live. These are the flights that could have a CDO, this flight on the left. So if you are in KLM 835, in a few days, you will be able to experience it from inside. And these are the flights that have been rejected, and all of them, this one is from Singapore Airlines. And here you have an explanation why it has been rejected. Okay, so this is an example of prototyping, and the air traffic control will have a tablet with this recommendation on the left. We will not show why we are not selecting and so on. This is for us to refine it. But this is, in this one has been accepted by ATC. It's not the case. It has been accepted by some operator in our office. But you can see an example of how we are using the information live, extracted through the cabinet that you saw, and then process it again in the cloud, and we are able to offer an advice. Okay. So if you have any question, now is your chance.
Thank you, Gabriel, for the air traffic management ATM. I was actually thinking was the ATM, the
money
auto teller machine. Do we have questions from the audience? Raise your hand and I'll approach
you. Or do you simulate faults?
You can simulate faults like this. But in this case, the use case that you're seeing is more about prototyping, of creating a new functionality, which is what you were seeing in this session, advising something. But you could also make a replica of the system. For instance, what is very common, and this is something that we want to do, is to have the same system running with two different configurations. The configurations of the Airspace change twice a year, and you need to input them into very old files, manual files, with a lot of commas and stars. And sometimes you put them in the system and they don't work, or they have a strange effect. Thanks to this, you can just make them go through a twin and see if the behavior of the system is different. Or for instance, another thing that you can do is check the consumption of memory or the consumption of CPU of two different versions running on the same data. And then you see if there's something in the dynamic behavior of the application that could be wrong. No, this is not replacing the legacy. This is just helping the legacy. And many of the things that we are learning here will be there in the new system. There's going to be a new system around 2030, 2029, 2030. We still have to start to build it. But all these things we are building and we are learning for the next system, including the use of APIs.
Other questions from the audience? Gabriel, thank you very much for the presentation. It was great. I have one question, which is more about the entire journey. Like how you are working the air traffic management. How was the learning experience? What was the journey for your developers, product managers to get to know the technology, the platform? So if you could briefly.
So I can tell you I've been in the air traffic management business like for 20 years. I think it's especially interesting because, the fact that you are flying, somebody is keeping you safe is very interesting. In the case of Singapore, AirLab is a lab supported by the National Research Foundation of Singapore. And our intention is in part to give opportunities to people from Singapore to learn about our sector. Because there's a lot of competition. You can work in many places, but we need capability in technology, in air traffic management in Singapore. So my own experience is very long, but there are opportunities for local people to actually work in these kind of environments because the country needs you guys. We cannot keep being a leader as we are now in Changi and having an airport like this if we don't have the ecosystem of people to support it.
Thank you.